This is Team 7, which has Priyanshu Mathur, Rohit Kumar, Devanshu Gupta, and Saurabh Mishra. And in this video, we'll explain how to calculate the packet delivery ratio for network design in NS2 using AWK script. The first part will be explained by Rohit Kumar.
And my name is Rohit Kumar. First thing we have to do is to create a network simulator object, which gives us access to all the member functions to create nodes and define the links between them. So as you can see, in the first line we created an NS object. After that we are creating a trace object NT, which is trace file is a file which have all the information about the communication between the nodes. By this file we can find out how the packet had transferred from one node to another, how much time it had taken, what was the size of the packet, and so on. File, we are using the trace all function of the NS object to trace all the information about the communication between the nodes to the trace file using the and take a look at the trace file of our program. As you can see, there are mainly 12 columns in the trace file. The first column contains the name of the event, where plus sign means packet enters to the queue, minus sign means packet exits the queue, R means packet is received by the node, and D means packet is dropped. After that, there is a column for the time of the event. Column 3 contains sender's node and column 4 contains receiver node. As you can see here, the sender's node is 0 and receiver node is 1, which we will see afterwards in our program that we have set the names of the nodes. Column 5 contains the type of the packet. As we are using TCP agent in our application, so there is FTP and AKW, where AKW is the packet created and sent by TCP sync agent. Now in column 6 there is packet size. After that, in column 7 there are flags. As you can see, there are no problems in our program, so there are no flags in column 7. Column 8 contains the flow number which packet belongs to, and column 9 contains the packet sender. For example, in our program the value is 0.0, which means the node with ID 0 sends data from port 0. Column 10 contains the packet receiver. For example, in our program the value is 2.0, means that the node with ID 2 receives the data by port 0. Column 11 contains the sequence number of the transmitted packet, and column 12 contains the ID number of that packet. Afterwards, we will see in our program that we have given unique ID number to each node so that we can use it in our program. As you can see in the trace file, the only ID numbers that are available are 0, 1 and 2 only, because we have defined that in our program. Now let's get back to our main file. After creating the object for tracing the file, we create the object for tracing all the events in pdr.nan file so that we can visualize the program. As you can see, we have given the right permission to NF object so that we can trace all the events in that NAM file. After this, we are just predefining the colors for our node so that we can use it in our program afterwards. As you can see, we have defined a total nodes variable which have the value 3, because we need only 3 nodes for our program. After that, we are creating the nodes and simultaneously giving them IDs. As you can see that we have created a for loop in which we are creating 3 nodes and giving them IDs at the same time. After that, we are giving name to our nodes. As you can see, we have given 3 names to our 3 nodes: server, router and client, where the ID is 0, 1, 2 respectively. After that, we are creating the duplex links between our nodes. As you can see, we are creating the duplex link between server and router, where we have passed 3 arguments: 2 MB, 50 millisecond and drop tail, where 2 MB is the maximum bandwidth, 50 millisecond is the timeout, and drop tail is the method we are using. In drop tail method, when the queue is full, the remaining packets are dropped. After this, we have created the duplex link between router and the client, where the parameters are same as server and router. After this, we are defining the orientation for our 3 nodes. As you can see in the animator, the server is the first node, router is the second node, and client is the third node. So what we have done here is that we have given the command to NS that put router to the right to the server and put client to the right to the router. Now the explanation is continued by our team member Priyanshu Mathur.
So I am Priyanshu Mathur, and I will be explaining labeling, coloring and assigning shapes to nodes, and then like how can we attach TCP to server and client nodes and how to interconnect them. So at line 41 to 43, we assign each node with a name. So that is, we label the nodes as server, router and client at timestamp 0. And then in lines 45 to 46, we assign colors to the nodes: blue color for the node which is labeled as server, and red color for the client node. These are also assigned at timestamp 0. And then at line number 48 to 49, we assign shapes to our nodes: both the server and client nodes will appear in the hexagonal shape. Then at line number 53, we set the agent as TCP. This type of agent appears in this line, and it gives a pointer called TCP to the TCP agent, which is an object in NS. Then the next line defines the source node of the TCP connection. That is, it attaches transport agent to the sender node. Then in the set sync line, we define the behavior of the destination node of the TCP and assign to it a pointer called sync. Then in the next line, we define the destination node and attach the transport agent to the receiver node. And at last, we finally connect the source and the destination node using TCP connection.
Hello, this is Devanshu Gupta, and in this part of video we will understand the setup of FTP source application and TCP agent. FTP is an application and protocol used for file transfer, and it uses TCP for transport. So in line 37 we are creating an FTP source application, and in the next line we are attaching FTP with TCP. Now we will transfer the data from one end to another, and for that we will start FTP at 1 second, and in the next line we are stopping FTP at 6 seconds. In the next function, post simulation processes are specified. The proc finish will generate a procedure in which we call the global variables ns, nf and nt. Next line will flush the trace what have been done in the name file. exec name will execute the pdr.name file. Now we will just exit from the procedure. In the next line, we are calling finish procedure, and then we run using $ns run.
This is Saurabh Mishra, and in this part of video, we'll understand about packet delivery ratio and awk scripting. The packet delivery ratio (PDR) is defined as the ratio of received packets by the destination to the generated packets by the source. PDR is calculated using awk script, which processes the trace file and produces the result. Awk is a high-level programming language used to process text files. Awk scripts process the data from logs and trace files, which we get from NS2. Awk script structure contains mainly of three parts. As it appears on the screen, first part names begin. It deals with what to be executed prior to text file processing, which is used to initiate variable values or constants. Here we initialize the variables named received, drop, total and ratio with the value 0, and these variables will help us calculate. The next section is named as context. It is a script which processes the text file. In this part, awk moves line by line and executes the action set if current line matches the pattern. This action is repeated till awk reaches end of the file. Awk scripts process data column-wise. For example, here we define columns with the name as $1, $2, $3, and it can go on up to $52 in a trace file. $1 means action, $2 means time, $3 means time value, $4 means node ID, etc. Column number 1, the $1 takes value as S, R, D or F, which are sent packet, received packet, dropped packet and forwarded packet respectively. Similarly, the column number 4 is the destination node ID. Here in first if condition, if column number 1 takes the value R, that is the packet has been received, and column number 4 takes value 2, that is it has been received by the destination node ID 2, then we increase the received number of packets by 1. In the next if condition, if the column number 1 takes value D, that is the packet has been dropped, and the column number 4 takes value 2, that is the destination node ID was 2, then we increase the number of dropped packets by 1. The last part of the awk script contains end. It explains what to be executed after text file processing, that is what to show or print as an output in the terminal. Here in this section, the output is printed as total packets dropped, total packets sent, and the packet delivery ratio, which is equal to receive upon total into 100. In the last part of this video, we'll take a look at network animator or NAM. Here, it consists of 3 nodes, namely node 0 as server, node 1 as router, and node 2 as client. The data transfer over FTP begins at 1 second and ends at 6 seconds. As you can see, the green colored packets denote that all packets are received and none are dropped. After 10 seconds of packet transfer, the FTP application stops and the trace data is flushed into the trace file and the process stops.